Okay, so in 10.5, we're going to talk about angle relationships in circles. So, like when a chord intersects a tangent or another chord, things like that. So, how angles are formed with what types of lines or segments and what those angles show. So, Theorem 14, the tangent and intersected chord theorem, says that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half of the measure of its intercepted arc. So, if arc AB was 80 degrees, then angle 1 would be 40 degrees because it would be half of that. And if the arc ACB was whatever would be left, 280 degrees, then angle 2 would be half of that, or 140 degrees. So it's just half of the intercepted arc. So in these first three, line M is tangent to the circle and we're just finding each indicated measure. So in number 1, we want to solve for angle 1. So we know that this arc here is 210. So angle 1 is going to be half of that, or 105 degrees. In number 2, we want to find the measure of arc RST. So this angle is 98. So that 98 degree angle would be half of that arc RST. So to solve for that arc, we are going to multiply 98 by 2 to get 196 degrees for that arc. And then in number 3, we want to know the measure of arc XY. So that angle, 80 degrees, would be half of that arc XY. So we're going to multiply the 80 by 2 to get 160 for arc XY. So when we talk about intersecting lines in circles, if two non-parallel lines intersect a circle, then there are 3 places the lines can intersect. They can intersect on the circle, in the circle, or outside of the circle. So in Theorem 15, angles inside the circle theorem, if 2 chords intersect inside the circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So for angle 1, we're looking at arc DC and AB. So we would add those two together and divide by 2. If we wanted angle 2, we would take arc AD and BC and add those together and divide by 2. If angles are outside of the circle, Theorem 16, we've got 3 possibilities. If a tangent and a secant, 2 tangents or 2 secants intersect outside of a circle, then the measure of the angle formed is 1/2 the difference, so we're subtracting, of the measures of the intercepted arc. So for a tangent and a secant, if we wanted to find angle 1, we would do half of BC minus AC. If we needed to know angle 2, we would do half times PQR minus PR, so the bigger minus the smaller. And then if we needed to find angle 3, we would do the arc XY minus arc WZ and cut it in half. Okay, so in 4 and 5, we're going to solve for our variable. So we need to know what y is in number 4. We know the opposite arc, and we know this angle is 102. Well, we really need to know one of these two angles, which would be the same. And luckily, it forms a linear pair with that 102 degree angle. So linear pairs add to 180, which means that this angle has to be 78 degrees. So what we know is that that 78 degree angle has to be equal to half of y plus 95. So it has to be equal to half of those two arcs added together. So I'm going to solve for y. I'm going to multiply both sides by 2 so that I don't have to distribute a 1/2 and deal with a fraction. So 156 equals y plus 95. And then to get y by itself, I'm going to subtract my 95, which leaves me with an arc of 61 degrees. So in number 5, we're doing similar things, but our lines are meeting outside of the circle. We have two secants that meet outside the circle. So instead of adding our arcs, we're going to subtract them. So that 30 degree angle is going to equal half my bigger arc, which is A, minus my smaller arc of 44. So again, I don't want to deal with the 1/2, so I'm going to multiply both sides by 2 to get 60 equals A minus 44. And then to get A by itself, I'm going to add 44 to 60 to get 104 degrees for arc A. So one more vocab word is a circumscribed angle. So a circumscribed angle is an angle whose sides are tangent to the circle. So we've seen circumscribed angles already when we started talking about tangent lines on a circle. We just didn't call it a circumscribed angle. And so our last theorem for today is 17, which is our circumscribed angles theorem. And it says the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So basically, if we take the center of the circle and connect it to the points of tangency for the two tangent lines, we're going to do 180 minus this angle here. And that's going to give us this angle D outside of the circle. So in number 6, we're solving for x, which means that we have this central angle of 120 degrees, and we had theorem 17 that said that this angle outside of the circle, when it was formed by two tangent lines, was going to be equal to 180 minus the central angle. So in this case, x is going to be equal to 180 minus 120, which is going to give us 60 degrees. And then when we look at number 7, we need to find x. Well, we know that this x is going to be half of whatever this arc is because it is an inscribed angle, but we have to be able to find that arc first. So what would be helpful is if we knew this central angle PRQ. Well, we can find that because angle PRQ, much like what we did in number 6, if that angle N has to be 180 minus the central angle has to be 180 minus the angle outside formed by the two tangent. So angle PRQ has to be 180 minus 50, which is going to equal 130 degrees. So if that central angle is 130 degrees, then the measure of my arc PQ is also 130 degrees. So I can solve that inscribed angle by taking half of that intercepted arc, which in this case would be 130 degrees, which is going to leave me with 65 degrees for x. Okay, so in number 8, you're on top of Mount Rainier on a clear day. You are about 2.73 miles above sea level at point B. Find the measure of arc CD, which represents the part of Earth that you can see. So in order to find this arc, we need to find what this entire angle here is. So we know that AB is 4,002.73 miles, and we know that AD is 4,000 miles. So we can find this angle here using our trigonometry. So from this angle, 4,000 would be our adjacent side because angle D is a right angle. And AB, the 4,002.73, would be our hypotenuse. So adjacent and hypotenuse is going to be cosine. So the cosine of that angle is going to be 4,000 over 4,002.73. So to find angle A, we're going to do that inverse cosine. So in our calculator, we're going to do second cosine of 4,000 divided by 4,002.73, which gives us an angle of about 2.12. Now, these two triangles, ADB and ACB, are congruent to each other because AC is also 4,000, AB is still the same, and if we did Pythagorean theorem, CB and DB are going to be the exact same thing. So we have two sides of the angle, two angles that are both 2.12 degrees. So that whole angle CAD is going to be about 4.24 degrees. And central angles have the same measure as the intercepted arc. So arc CD is going to be about 4.24 degrees.